Next step, we will dive into, there is a concept called sampling distribution. The sampling distribution is a key concept in inferential statistics. It represents the distribution of a sample mean across all possible samples of a given size from the same population. The key idea behind this one is we take multiple random samples from the population. Supposing, for the sake of simplicity, in a population, I have only 4 values, 1, 2, 3, 4. You draw 6 samples from this population, and each sample size is 2. And your next one is for these 6 samples, you compute the mean. The distribution of these means of all these samples form the sampling distribution. It is as simple as that. So the definition is the sampling distribution is the distribution of the sample statistics with nothing but the mean from all possible samples of a given size from a population. And other point, what you need to note down is the sampling distribution of the mean is normally distributed with the mean equal to the population. This we will take sample data and then we'll work it out on this. And then I'll show you how the sampling distribution mean is equivalent to the population mean. Whether it is true or not, that I will justify that with the, with the sample data. The next one is the sampling distribution of the standard deviation is also equal to the population standard deviation divided by the square root of the sample size. So, now what I will do is I will just go to the Excel and I will demonstrate how it is, how I'm going to justify how the sampling distribution mean is normally distributed with the mean equal to the population. Okay. Mean equal to the population. First thing is, these are the 4 values that are available in my population. The mean for this population is 2.5. And the standard deviation is, let's forget about the sample in a standard deviation. Let us look at, let's compute a little later. For example, in this sample, I'll be drawing, sorry, in this population, and this 4 values, right? This is my population data. So I have drawn 6 samples. So 1, 2 is sample 1, and 1, 3 is sample 2, and sample 3 is 1, 4. Similarly, 2, 3 and 2, 4. So 2, 3, 2, that is my sample 4 and 5. Sample 6 is 3, 3 and 4. This is my sample 6. I've drawn 6 samples. The next step is we are going to compute the mean for each sample. 1 plus 2 is 3. 3 divided by 2 is 1.5. 1 plus 3 is 4. 4 divided by 2 is 2. 4 plus 1, 5 divided by 2 is 2.5. Likewise, up to this 3, 4, sample 6, we have computed the mean. Forget about the rest of the values, okay? So these are the means for the 6 samples. Now, these statistic or the mean forms the sampling distribution. The distribution, if you plot it in a chart, right? So look here, listen, if you plot it in a chart, something like this. So you have 1.5 and 2, let's say 2.5 is there here and 3, 3.5. So in this case, we did not plot the values as it is. Instead, we have plotted the means in the x-axis. Okay, the distribution of the means is nothing but sampling distribution. It is as simple as that. So in this case, right, our population is very small. Only we have 4 values, 1, 2, 3, 4. So, with that, we can easily compute all possible sample means and then calculate the standard deviation of the sampling distribution. For that reason only, I've taken only 4 values. So in this case, we have drawn this sample with size 2. Each sample, we have only 2 values in it. Okay, we have calculated the sampling distribution of the mean also for all possible samples of size 2. Look here, the next step is calculate population mean and standard deviation. We have already calculated the population standard deviation. Sorry, mean is 2.5, and the next one is the mean for these 6 samples. The means of these 6 samples. You add all these 6 samples values divided by 6, you get 2.5. So now the first statement, the second statement is true. The sampling distribution of the mean is normally distributed with the mean equal to the population. The sample distribution mean is equal to the population. So sample distribution mean is 2.5 and population mean is 2.5. That is what this statement tells. And again, the mean is normally distributed. This one we will check it out little later. Okay, if you plot these things in a chart, the mean, if you plot these mean, it is approximately normally distributed, but here it is, yeah, it is kind of approximately normally distributed. Okay, so as you draw more samples, it will approach to more precise normally distributed data. For example, in this case, I have selected only these 6 values. So in this chart, if you see the select data here, look here, only these 6 samples means only I have plotted it here. And if you, in this chart, if you see here, I have selected, no, here apart 6, and then what I did, I have drawn 4 more samples. As the sample size increases, as per the central limit theorem, it approaches to normal distribution, approximately normal distribution. Look here, now considering, when I plotted all these samples means, I can see that it is a kind of a normal distribution. That is what this second statement tells. So within this second statement, we can see that the sample distribution of the mean is normally distributed. Yes, it is normally distributed with the mean equal to the population. Yes, the sampling distribution mean is equal to population mean. We are done. The next one is the sampling distribution of the standard. Like how we can find out the mean for the population and the mean for the sampling standard sampling distribution. We can also find out the standard deviation for this sampling distribution. That is what I did. Look here, standard deviation of these values. And then this is equivalent to the sampling distribution standard deviation is equivalent to the population standard deviation, which is nothing but the 1.118 divided by the square root of sample size. That is the formula. Look at the sampling distribution of the standard deviation. This is what the standard deviation I computed. It's pretty simple. Like how we can find out the standard deviation for the data. We can also find out the standard deviation for the means. In the case of sampling distribution, that is called your sampling distribution standard deviation. This sampling distribution standard deviation is equivalent to the population standard deviation divided by square root of n. So you can see that J6, this one divided by square root of sample size. In this case, the sample size is just 2, right? 1, 2, 1, sample size 2, and square root of 2. So this one gives me 0.790545. So hence, the calculated value of the sampling standard deviation is very close to the theoretical value of 0.79. So what do we conclude here? The sampling distribution with the mean equal, the mean of the sample distribution is equal to the population mean. That is the one I demonstrated here. That is the one I demonstrated. The sampling distribution mean is equal to the population mean. Similarly, the sampling distribution standard deviation is equivalent to the population standard deviation divided by square root of n. In this case, the n is 2 because the sample size is 2 here. Sigma is this value. And if you compute this, you'll get 0.7. This value is approximately equal to this value. Okay, the sampling distribution standard deviation value is approximately equivalent to the population standard deviation divided by the sample size. Hope you understood with this sample data what is sampling distribution is all about. Now the question is, what are the advantages of sampling distribution? It gives us the basis for inference. It gives us the basis for inference. What do you mean by inference? It provides the foundation for statistical inference. Right. So in this case, by studying the distribution of sample statistics obtained from repeated sampling, we can make inference about the population parameter. And also, the other advantage of using sampling distribution is the estimation of population parameter. The sampling distribution helps us to estimate the population parameter based on the sample means which are also called as sample statistics. For example, the mean of the sample distribution of the sample mean is an unbiased estimator of the population mean. That is what we have seen it. And apart from this, it helps us to understand the sampling variability, how far each sample mean is away from the population mean. Okay, and that also we can find out the variability. And the next one is it helps us in the sample distributions helps us in constructing the confidence interval, which provides a range of value that is likely to contain the true population parameter value with a specified level of confidence. That one we will take a deep dive in the next session. And we have something else called hypothesis testing. Even in the case of hypothesis testing, the sampling distribution forms the basis for the hypothesis testing. So we will discuss in detail about the confidence interval hypothesis testing in the later session. The next topic we'll discuss about what is confidence interval. To summarize, we discussed about the sampling distribution. The sampling distribution is the distribution of sample statistic or the mean from all possible samples of a given size from a population. The sampling distribution mean is equivalent to your population mean. And also the sampling distribution standard deviation is equivalent to the population standard deviation divided by the square root of sample size. That is what we discussed.